Now, the next step here is we're going to take a look at how we're going to go ahead and program this part. So like we talked about in the machining workflow, the first step is to create a roughing toolpath so we can rough the stock out to bring it as close as possible to the finished shape of our part geometry. So to do that, I'm going to go over to the 3-axis methods and then select horizontal roughing. Now, horizontal roughing is also called as known as Z-level roughing because it does roughing in levels. So in the horizontal roughing operation, you do not have to select any part regions or part surfaces. If you'd like to rough the entire part out based on the part and the stock that you define, you can skip the selection of part regions under the control geometry tab, select your tool for the operation, set your feeds and speeds, set your clearance. It's set to automatic, so we are working over from left to right as we work through each of these tabs in the roughing operation. Under cutting parameters, we specify the tolerances, the stock allowance. By default, roughing operation leaves 25,000 stock. So you want to then go back and do a pre-finishing and a finishing operation to remove the stock. You can change these parameters and values. You could choose the cut pattern, your cut directions, step over, cut levels, which is basically stepping down in levels, specify engage and retracts and any advanced cut parameters, and then pick generate. So selecting generate, the system automatically computes a roughing toolpath based off the part and the stock. And I've just generated the roughing toolpath with the default parameter settings, and you can view the toolpath in levels. Once it's generated, you can see each of these cut levels based on the step down, which is 50% of the tool diameter. So it's stepping down 1/4 of an inch for each pass. So I'm going to go ahead and switch to the simulate tab and run a cut material simulation to validate our roughing process. And at any time during the simulation, if you want to speed it up, you can use these simulation controls in the slider bar right below preferences. You could also choose pause and then pick simulate to end to run through the simulation. So as you can see in the cut material simulation, we've done a Z-level roughing. So roughing it down in levels. Also, you can see these stair steps. So roughing it down in different steps. And if I switch back to the program tab, you will actually see the part and the stock. You can toggle the visibility of the part and the stock. So the roughing process brings it as close as possible to the net shape of the part, and it leaves the stock that is specified to leave in the cut parameters tab. Now let's dive into some of these parameters in roughing and take a look at it. So the first thing I'm going to go in is to the cut parameters tab, and we'll talk about how the tolerance affects the toolpath. So as you take a look at this particular toolpath that we generated, if I step down to levels here, you can see that the slacker the tolerance that you've set, you're going to probably see that the deviation is within the tolerance, and you'll see, the chord segments, the toolpaths are much faceted in here. So the tighter the tolerance, you'll have much smaller chord segments, which maintain it within the accuracy of the tolerance that you specify. Now, to illustrate this, I'm going to go ahead and switch back to our slide in here. And you can see the effect of machining tolerance. So a tolerance of 0.1 versus 0.01 and a tau. So basically, the slacker the tolerance, you'll have fewer chord segments. Tighter, it'll make it more number of chord segments, and you can also fit arcs to the toolpaths to by defining these arc fitting tolerances in the advanced cut parameters tab. Here's also an effect of the tolerance. You can see the in tol and the out tol, setting the tolerance to a slacker value versus setting it to a tighter value. So it makes it more accurate, tighter of the tolerance. I'm going to switch back to RhinoCam. So you can see the effect of tolerance right in here. We'll go back into the roughing operation, and we'll tighten up the tolerance. I can tighten it to 1,000. So remember, when you tighten up the tolerance, you want to make sure if you're fitting arcs to your toolpath, you set your arc fitting tolerance to 2 times of the parameters that you specify in the intol and the outtol. So we're setting it to 2 times, and then we'll pick generate. So once the toolpath is generated, this would result in much smaller chord segments, and you can see the toolpath, it's much more accurate, maintains it within a tolerance of a tau. So let's go ahead and run the simulation in here. And I'm going to skip by doing a pause, then selecting simulate to end. So we've now generated a roughing toolpath with a much tighter tolerance. Now there's a few other parameters we would like to talk about in the cut parameters tab. So we have core and cavity and core region. So what is a core region and what is a cavity region? So we have different cut patterns available for cavity regions and core regions in here. A core is like a core feature that is basically like an island or a feature that is sticking out on the model. So where the cutter can approach itself from outside the material and work its way in towards the part. So you can specify the cut pattern and cut direction and the step over for core features. So in this particular example, we have a core feature. So I'm going to set the step over as 40% for the core feature. And then if you had any cavities, this particular model, we do not have any cavity features. I'm going to give you an example of a cavity feature as well. And you can set the tolerance, you can set the cut pattern, the cut direction, and the step over for cavity features. So you can control the step over and the cut direction for core and cavity features independent of each other. So while the toolpath is being generated, I'll switch to a model to show a cavity feature. Now this could be, this pocket in here would be considered as a cavity feature. Or if I go into one of the other files in here, I have the cavity of the same mold we looked at here. So this would be considered as a cavity feature as well. So for this, when you program a roughing toolpath, you would apply the cavity cut patterns that you have for the cavity features on a model. So core versus cavity. Now, if you'd like to apply a cavity cut pattern toolpath for the core feature, you can do so by clearing this checkbox. It says use facing cut pattern for core regions. When you clear the checkbox and generate the toolpath, this will apply the cavity cut pattern toolpath. So the cutter ramps in at the specified ramp angle, as you can see right here, and then applies a cavity cut pattern. So in this particular case, I'm going to go back and apply a core cut pattern and specify the parameters for the core cut pattern by selecting the core facing region cut patterns tab. So the next important thing I would like to talk about here is the cut levels. So the cut levels is the distance in Z levels, so how much of material you would like to remove per pass in the Z. This could be set to a % of tool diameter, or you can choose a distance, or even specified by number of levels. And you can also contain the cut levels by specifying the top containment and the bottom containment as well, if you want to restrict the toolpaths in the Z. Engage and retract tab allows you to specify how you would like to ramp in for cavity regions, and how you'd like to engage for core regions to engage the cutter from the outside. And advanced cut parameters allows you to perform arc fitting, smooth cut connections, and cut rounding.